Okay, for the power, the excavator comes with this 7.2 volt battery. It's reasonable, 400 milliamp hours. It's easy enough to replace this with a higher capacity battery, but I find that I can run this thing for a good hour before I have to recharge it, so it's not that big of a deal. But I didn't want to have to obviously run the Raspberry Pi on a separate battery than this, so the good guys at Core Electronics just turned me on to this little device here. This is a Polo LU 5 volt step up, step down voltage regulator, S7V7V5. I'll put that in the bill of materials. And so this little device, you can, if I can get the focus on there, it's got a simple, on the back it tells you, turn it around here, you have a common ground, voltage in, voltage out. So you can throw a voltage in anywhere between, I think, 2.7 volts and 12 volts, or almost 12 volts, 11.8 volts in the voltage in, and you'll get a good solid 5 volt output. And I forget the amperage that it's capable of, but more than enough to run this little Raspberry Pi. So very simple solution here. So the idea is to get the 7.2 volt battery, which normally would go onto this header here on the dark water and control the different motors, but take a feed off of that into the voltage in, take the voltage out, and run the Raspberry Pi. Now there's a lot of controversy and things on the blog as to whether it's safe to power the Pi directly through the GPIO pins or not. There's ways of hooking into the USB to make it a little bit more safe, but the amount of amperage that should be coming through this should prevent anything really serious if you somehow short this out, but I doubt that would happen. So what I did is tied the voltage out right into this GPIO pin 2 on the Raspberry Pi, which is your voltage 5 volts. So plugged it right into that. So pretty much this thing can then run the motors at 7.2 volts and run this. Now I haven't tried it, but there's no reason I couldn't bring up an 11 volt power supply as well and run it. The motors would run faster, probably maybe too fast, but the voltage regulator would then continue to work and run the Raspberry Pi. So I could swap out the batteries pretty easily, and the dark water can certainly support 11 volt batteries if I wanted to give that a try. So let me show you this wired up on my device over here. What I wanted to do when I built this, and I'll just bring it up on the table here and kind of show how this works. Difficult to do with one hand here while I'm holding the camera. But what I have on here is here's the voltage regulator, and I just used some 3M tape, taped it in here, and then this is sandwiched in between the dark water and the Pi. Now, when I first started building this out, I purposefully used this header that would allow me to connect into the Pi through these male pins and leave the female pin headers on the top so I could continue doing my prototyping. If I were to do this again, I really don't need those because I've been just wiring right into the pin areas. So that is where the voltage regulator, so I bring right off of my 7.2 volts, bring right off my 7.2 volts positive and negative onto the voltage in and ground of the voltage regulator, which is right underneath this this taped area here. I just have it taped so that there's no shorting. And then my yellow wire here is the voltage out, which I go to GPIO 2 on my Raspberry Pi. So I'll plug the Raspberry Pi on here and show you how it looks with all this connected. One more thing to point out while I have it open here is I have a few other wires coming off of this, and this is GIPO headers for some of the different lighting that I have. So I've added some tail lights here to the device. I added a front light here, added a light to the top, a little yellow one there, and I have a light coming that's on order that's going to be put on the top of the cab. And I'm also going to set up, and I'll show you how to do it, for hooking up a camera to the front of this so that we can drive it even if we're not in the same area. So we'll see how that works once I get that hooked up. But let me show you what it looks like when it's all put together here. Okay, so I've just attached the Pi Zero onto the dark water. You can see it's got the double header here, which is not needed. So we can trim this down a bit, but because of these headers, it still takes up a little bit more space on that. You can see the voltage regulator is just kind of sandwiched in between there and managed through that. So that's the setup there, and this kind of tucks right in. I've just done some dremeling to get some space here, so it just tucks in right there. One of the annoying things about this particular device is the on-off switch, so I need to install one of those. Is the on and off switch on the original was hardwired to the board itself, so this was not mounted, so I couldn't reuse this switch easily. So I did pick up a switch, and we'll end up just get a switch down here. So I've got a switch here I've got to mount and get sorted to have an on and off switch. And so that's that setup, and then you just start setting up all the software, all the Python software to first of all just drive the motors through some Python scripts. That's the easy thing to get started with, and then I can show you how to pair up the PS3 controller to the Pi, and then how to set up whatever controls you want. So I have different controls set up, and I set up the controls based on a video game that my son likes to play, where he is a construction simulator, so I kind of set that up. But you can set up the controller however you see fit to control the device. So let me bring up the software and just show you a little bit about the motors running with just the some Python scripts.